Alright everyone, so today we're going to be doing Unit 7, Lesson 2, which is Factor by Grouping. So here's the standard that this concept relates to, okay? So let's talk about what factor by grouping is. It's exactly as it sounds. You're going to be grouping your expression into several different groups so that you're able to factor it, because there's not a GCF within the entire expression, so you're breaking it up to identify a piece that you can pull a GCF out of. And then once you are able to factor out a piece, you're then going to combine those pieces together, okay? So the steps are to group the first two terms together and the last two terms together. Look for the GCF in the first group and factor it out and write your answer as the GCF. And then look for a GCF in the second group, factor it out, and write your answer as the GCF. Remove the common binomial. This becomes your first binomial answer. And then put the leftovers in the next binomial. So basically everything that goes outside of the parentheses is what you're going to be grouping together into the binomial. So let's go ahead and do our first example. The example is going to really help make this make a little bit more sense. So we're going to be using our methods that we've been using to factor. So if we group these into two groups, all right, I usually like to put a little dotted line down the middle so I can identify the parts I'm grouping together. So what can I factor out of the left side? Yeah, the GCF, right? Which is what over here?
3.
So what is both 6 and 8 divisible by? Yes?
It's going to be by 2 and 3.
It's going to be 2b to the?
Squared by 3.
To the second.
Yep.
Because there's only 2b, so we can take out a 2b to the second, just like we've been practicing. And then what's left when we take out a 2b to the second?
It's going to be by 3.
Good. It's going to be 3. And then how many b's are left on the first term?
1.
1. And then what's left here? What's 8 divided by 2?
4.
Good. So we factor it out of 2b squared, which leaves us with times 3b plus 4. Now we're going to see what we can factor, what GCF we can factor out on this side. So, what can we factor out of a 9 and a 12?
3.
3. So a positive 3, right? Plus 3. And then what is 9b divided by 3?
3.
3b. And what is
3 times 4?
Good. 3 times 4. Good. So it's 4. So that's what you're able to factor out. And what do you notice about these two binomials right here? They're the same. This is the goal that you want when you're factoring by grouping, okay? So now, I want you to take whatever came on the outside and put that into a set of parentheses together, okay? So you're going to group together what went on the outside of those parentheses. Then, you're going to take what is in the highlighted region, what both of them have, and that's going to go together into a binomial as well. So you take the leftovers, you put them on the outside, and then what they have in common goes right here. Make sense? Okay. Are we ready to move on to number 2? Okay. I just want to let you know, he told me that it was because of the assignment group. I changed them from important assignments, the title to assignments. And I resent yesterday, but I didn't check it yet. So okay. Check and see. Maybe it worked, maybe it didn't.
Okay, perfect.
You're welcome. All right, moving on to the next one. We're going to split this down the middle, and we're going to factor out of the left and factor out of the right. Now, what do you notice? I can factor out over here on the left. Is there any, yeah, an x, but x to the what?
Second.
Second, because there's only an x to the second in this one, so I can only take out an x to the second.
Okay.
This leaves me with 3x, because I have 1x left, plus, what's x squared divided by x squared?
1.
1. Now over here, guys, can you focus, please? Okay. So what can we factor out of this side over here on the right?
Nothing. It could be 5.
Good, 5.
5.
Yeah, so 15x and 5.
It's gonna be like 3x.
Good, it's gonna leave me with 3x plus
And it'll be 1.
1. Good job. So notice once again these binomials are the same, which is what we want, right? They have to be the same for this method to work, okay? They have to be the same. So whatever is on the outside of your parentheses gets grouped together.
So that would be x squared
Plus 5. Good. And
Would that
then
equal 25?
No.
whatever they had in common goes right here.
You don't add them all together.
Now, theoretically, if you wanted to check your work here, you could multiply these all together. Okay, you could use FOIL or box method, area model. So you can check your work by doing the opposite, okay? So, before we move on, does anyone have any questions about this one?
No.
Alright, ready to try the next one? So now we're going to try number 3. So once again, we're going to split it down the middle. We're going to factor on the left and then the right. What do you notice we can factor out on the left? Bigger than a 2, we can take out a 4 and then r, right? We have an r in each of them, so we can take out an r. Which is going to leave me with
r plus
not r, but r squared plus 6.
Yep.
And can we factor anything out over here?
No.
1.
We can factor out a 1. Good. So if we factor out a 1, that's going to leave me with r squared plus 6, right? So see how we couldn't factor anything out over here, so we just simply factor out a 1. So when you can't factor anything out, you're just going to factor out a 1, which is always okay to do. Now, once we have that, we have these two binomials, which are identical, right? Which is, yes.
How the 6 on like the right side of the equation stays the same?
Over here?
Yeah.
Because it's 6 divided by 1, which is still 6. When you factor out, you're dividing it by that thing you're factoring out. So when you divide something by 1, it doesn't change it. Does that make sense? So if you were to like list out the factors of this, it'd be 1 times 6, 2 times 3.
Oh, because there's only one number you can divide it by because of the variable not having a different number in front of it?
Yeah, because this is technically a 1, and then that would just be 1 times 1. So the only thing they have in common is the 1s, which is what I'd have to factor out. You're welcome. So then we are going to group together the ones on the outside. That's going to become a binomial. And then what's in the highlighted region is going to be multiplied by that grouping, okay?
Stop the video again.
Chat, are you taking notes?
I don't have a pencil.
That's why you ask for one. So, we are going to split it down the middle. What can I factor out on the left?
5.
A 5 and a t.
Squared.
Not a t squared because this one only has a t. So I can only factor out the term with the lowest t, right? I can only take out one t because this one only has one t to give. So this leaves me with t plus 6. Now over here, I remember my goal is to get these two binomials to look the same. So what's wrong with this one that is close to looking like this one but not quite? What's the difference? The negative. So to make something positive, I can divide it by a -1, right? If it's negative, I can factor out a -1. So that's going to make everything positive when I factor out the -1. That's going to be t plus 6. And you can always check you've done it right by distributing the negative back out and making sure that you have what we started with, okay? So then, from here, we group together, we see and identify that these two binomials are the same. Now, if these two binomials are not the same, you can't do factor by grouping. So you either made a mistake somewhere along the line, or they're not simply not factorable. So these group together, and then whatever's in the parentheses that they have in common goes out on the outside. And this is what you're left with as your result. Does anyone have any questions? I will zoom out